Hey everybody, and this is the video for the research paper Flash Attention 3, Fast and Accurate Attention with Asynchrony and Low Precision. And this is put out by numerous institutions. So it's Colfax Research has top billing, and then Meta, NVIDIA, Georgia Tech, Princeton University, and Together AI. The interesting and the bottom line thing to me overall as to what this does is it essentially gives speed ups of up to 1.5 to 2 times performance on the forward propagation, and then 1.5 to 1.75 times performance increases on backwards propagation. Very specifically, though, it's important to note that all of this is related towards tensors. And then so essentially what Flash Attention 3 is very simplistically, it's software, right? It's an algorithm. But this algorithm very specifically impacts hardware, but it impacts the hardware via the software, and then so all of this to say that in a nutshell, essentially what it what this actually does in a nutshell is allows for a floating point 8 precision, so like quantized like a quantization and quantized calculations for the attention like specifically related to attention to take place. So you can essentially have lower precision attention calculations, which is extremely important when it comes to the attention mechanism, because the attention mechanism has a very specific problem, which is that the the more parameters that you put within the neural network, the more CPU and GPU that is required for the attention mechanism, because the attention mechanism touches every single parameter or every single neuron within the neural network, right? And then so to give this a simple analogy, let's use the analogy of like a classroom. And then so let's say that you have a classroom and you have students passing notes in the classroom, right? And then so if you have 30 students and they're all passing notes to the teacher, that's a very simple equation, right? That's 30 notes that get passed. But then if we have 30 students and then each student has to pass a note to each student, then that's 30 times 30, right? And then so that becomes a much more complex equation. So like right off the bat, we're already at 900. And then if we jump that if we jump that like significantly, then it jumps exponentially. Like if we put instead of 30 students, if we have 300 students, it goes up to like in that particular instance into like the tens of thousands immediately, right? Like there's the next iteration, and then from there we go into like millions, and then like exponential numbers from there. And so that's what happens with attention is that you have this exploding problem where it has to touch more and more, and then so it becomes more and more GPU and CPU intensive. And then so what Flash Attention 3 does in this instance is it allows for a lower precision. So again, like a decrease in the amount of computation required and the amount of accuracy that you get out of the actual end calculation. But within that, what it allows for is to trim and decrease the amount of CPU usage that's involved within this calculation and for this particular problem. And then so in this instance, we can see again it increases. We have increases of utilization up to about 75%, which is very significant in this instance, right? And then so this paper in and of itself is very significant into what it does as far as like increasing the performance. Thing to highlight within this is that this paper does take advantage of very specifically of the hardware innovations that are current within like the very newest NVIDIA GPUs. So it's like the H100 or higher, which is like the H100 is like $10,000 plus GPU. So it's like only for like this is like only for cutting edge, right? And it does require the hardware, and then that's the interesting thing to me, and I keep coming back to this, is that so this is an algorithm and it impacts the software, but it's directly impacting and improving the performance of the hardware and increasing the performance of the hardware. and all of this is interrelated. And then the number one thing to highlight within this, like overall, is that all of it is related, and all of it is related to NVIDIA GPUs very specifically, right? This is impacting tensors very specifically in the tensor process, and the tensors are a part of the hardware process of NVIDIA GPUs very specifically. So when you wonder why is NVIDIA all of a sudden the number one company in the world, and like how does that come about? Where does that come from? All of that, like they're giving you a masterclass in this, right? So like they're putting out third-party technology and like third-party research that is like universal, like it's like universally impactful, but at the end of the day, it's only like it really only is beneficial for their own hardware. Like that's how it just works out, right? And they uh, and you can make argument like they're well, that's not their fault that that's the only one that it only works on their hardware, right? Which is what they lean on within this, and like how they get like extremely good publicity out of this. But like that's it, like essentially they're building up their moat and their monopoly harder with this type of release, and everything. Like I'm praising it. Everyone is going to praise it, right? This is going to be praised as a great release, which it is for what it is overall. But I think it's important to highlight and just point out that on the back end, this is an extreme masterclass from NVIDIA as to like how to take advantage of this particular situation. And then so giving that kind of just unique take on this paper. I think there's going to be a lot of takes on this paper, and so this is mine. And so thank you very much. And this is the lecture on Flash Extension 3.